There we go. Here's where you can find us for our keep tabs on the kinds of meetings that we're having. And then we will, I'll also drop a link. We use the R Consortium's Community Code of Conduct for the R Community Code of Conduct. So this is a friendly and professional space. And Andrew and I, who are the organizers, are here as moderators. And we are really glad that you're here. And we want to keep this environment to be a good one for us all to learn more about various R topics. I'm really excited for what we've got going today, and I'll do another quick announcement that we're going to be about to put out the time and schedule for March's meeting. So in March, we're going to do a meeting for folks who are actually in the Salt Lake area, like an in-person networking event. So we will post those details, and hopefully get several of you there to join us so that we can have some nice time to really meeting face to face. I love these remote meetings that we have as well because they're a really great way for us to get more people to be able to see what we're doing. And if you ever want to watch our previous events, you can go to YouTube. I'll drop that link here as well. And on YouTube, you'll be able to see some of our past meetups and the live streams. Oh yeah, that's a great link that you shared there, Andrew. That goes straight to the past live streams, which is great for us to be able to share that info. All right. I am really pleased today that we have David Dahl with us. David, thank you so much for joining us. David is a professor in the chair of statistics at BYU. And David, you worked on so many different R packages, and I am pretty excited for you to join us here today to be able to tell about work you've been doing lately on using Rust in our packages. So David, I think before we get started, we're going to do this little poll for folks, right? So as we get started,
Sorry, might have
let's
been a little bit eager on the jump there.
no. Thank you, Andrew. Thank you. So we're gonna for those of folks who are here, if you want to answer this while we get up and started, that'd be great. So the first question is, have you ever created an R package? And then the second question is, have you ever included compiled code in R before? Have you ever like used something like C++ from R? So those of you who have joined us, if you want to give us some answers here, that would be great so we can understand who you are as we get started. All right, nice. Nice. So yeah, so David, thank you so much for joining us and being able to share a bit about how the approach you have taken to be able um, to use Rust from our packages. Thank you so much.
Fantastic. Thanks, Julia and Andrew, for the invitation to speak. It's really this is fun, fun stuff for me. Everybody can hear me okay?
We can hear you great.
Awesome. All right. So, I'm a statistician, and I feel like my job is to develop new ways to analyze data. And so I, come up with some awesome way that's going to analyze data, but of course it's going to be, somewhat involved in its implementation. And so I want to provide software to people so they can use it. Well, so how do I do that? So I want to make an R package. And in the past, I've tried to, make pure R packages, but then there's some speed implications of that. I've tried to use C++, I've tried to use Java, I've tried to use Scala, all to implement my stat methodology and get it out there to the world. But then I found that that just wasn't very satisfactory. But then I discovered Rust and I fell in love. So much so that my family knows I love Rust. And so my son made for me a little plushie. This is the Rust mascot named Ferris. And he's there with R on that graphic right there. Okay, so this is joint work with John Wetton. He is a former master's student at BYU who's now working at Pentara up in Salt Lake. So we want to kind of go through three major sections of the talk today. We're going to first talk about what Rust is for those people that may be curious but not really know really why would we want to use it for R. And that'll be pretty quick. And then we'll spend most of our time in section 2, where we kind of give a tour of how a developer could leverage Rust to make their R package. And then, of course, the curious folks will want to know how it works under the hood. And so we'll talk a little bit about that in section 3 and go from there. By the way, I'm really happy to take any questions as we go. I really don't mind if we don't cover all the slides or whatnot. So please, raise your hand in Zoom or whatever and ask a question. I think Julia and Andrew will help me monitor that if they would. Okay, so section 1, Rust, what and why? So the syntax looks familiar to developers in C and R. It's a compiled systems language for writing native code. It's comparable to C and C++ in that regard. It has the ability to make functions that comply with the C ABI so that we can have R call that using the .call interface. And R thinks it's calling a C function, but in fact, it's calling a function that was written in Rust. Now, when you think about Rust, you have to be understanding this concept of ownership and borrowing. And these rules that it has about ownership and borrowing are enforced by the compiler. As such, then a whole class of memory bugs that you would typically encounter in C or C++ completely go away in runtime because the compiler won't compile your code. You cannot write code that uses a pointer after it's been freed. You can't write code with the double free. You can't write code with the memory race condition. And so what that means is that an average developer like me can make really cool, fast, robust, concurrent code without a lot of the mistakes that have plagued me in the past when I've tried to write stuff in C++ or C. So the other nice thing about Rust is it has a very nice ecosystem tools that make things really easy to use. So there's a package manager called Cargo, which pulls down dependencies and is really very helpful. There's a formatter for your code so that your code can be formatted in a way that everybody else is expecting it to look. There's a linter, there's a testing framework. And what that means is that it's really easy to maintain code over time. They have a 6 weeks release cycle for the compiler. But the great thing is there's huge backwards compatibility guarantees. So you can have your code that you wrote back in 2016 still compile today on the compiler that was just released last week. Since 2016, it's been rated in the Stack Overflow survey as either the most loved language from 2016 to 2022. Then they changed the survey question and got rid of loved and changed it with admired, but still Rust was the most admired language then going forward. So it's been the top of the heap in terms of developer satisfaction for a very long time. You have to think about a different mental model, though. You have this idea that an object or a piece of memory is owned by something, and you can move the ownership from like one function to another, or you might want to borrow references to it, or you might want to borrow an exclusive mutable reference, but there can only be one mutable reference at a time enforced by the compiler. You also have to think about things like the lifetime of the object. Rust does not have exceptions, so there's no try-catch exceptions. Instead, functions can return a result, which either has the thing you want or the error. There's also pattern matching, which is really nice and makes for robust branches. So I mentioned that it's fast, and there's this language benchmarks game. And here's a plot that they have on their website. And this is Rust right here. I know it's hard to read, but here's Rust right here. You want to be close to 1, meaning you're as fast as C. And so C, C++, and Rust are right here. And they're all, within very close to each other. Here's C sharp. Here's F sharp. Here's Fortran. Here's Julia. Here's Go. And then this figure wraps over here. So here's Go again. And here you have stuff like Ruby and Perl and Python. They're like 70 to 100 times slower than C. The idea is that you get all these really nice things in Rust with memory guarantees and a really nice compiler checking for memory mistakes, but yet you don't sacrifice performance, which is, I think, the golden uh, reason for using Rust. Okay, so if you're going to develop an R package, you might want to develop a pure R package with maybe taking advantage of vectorization. And that could be fast, but you could potentially get into a bottleneck, especially if you're doing a lot of the logistics and the logic within R. So instead, you might want to jump down to like a low-level language like C, and you can code against R's C API, and that's going to give you maximal control, but you're going to have to be very careful about protecting objects that you create in your function from R's garbage collector. You have to make sure that the number of protects matches the number of unprotects. You have to manually register symbols that you can call the functions that you've defined. It's very error prone and it's very hard to debug. But excuse me, some people can do it and they do it great. I'm not a great programmer. I think I'm an okay programmer. And all these things lead to lots of frustrations for me. So I wanted to develop in Rust. Of course, before you get to Rust, though, you can think about developing in C++, which is what I was doing. And there's some nice frameworks. RCPP and CPP11 have been fantastically successful, and they're great. I think the problem is that you're still coding in C++, and I want to code in Rust. So I've developed this Roxido framework, which is what we'll talk about today. In interest of full disclosure, there are some other frameworks that you could use to develop Rust packages using other frameworks you could use to develop Rust-based packages in R. We'll talk a little bit about those when we go into the deep dive, and I'll show you some benchmarks. In short, they differ in terms of the API, in terms of what guarantees they provide, the ergonomics, the choices they made. They're not the same. Okay, let's take a tour then of Roxido. So in one slide, we'd say Roxido is just a collection of R wrappers over common C API patterns that are both safe and idiomatic. There's this macro called the Roxido macro, which you decorate your functions with. These are functions that you want to be able to call from R down into Rust. And this macro generates automatically the foreign function interface glue. It also performs automatic type checking that the thing that you passed, that R passed into Rust is actually of the type that Rust was expecting. But I want to emphasize that Rust and also Roxido has this very strong belief in something called zero-cost abstractions. And that is, there's no implicit conversions happening behind the scenes that could like slow your code down or that could take a lot of memory. All it's doing is the bare minimum, and you could not do any handwritten code that you write yourself would be no faster than the zero-cost abstraction that we provide. Also, we provide R bindings to RC API, so that if you find something is not covered in the Roxido framework itself, you can call into these bindings and call all of the C API functions. There's also a Roxido command line interface, a command line program that helps you to generate a new package or to update your package to the latest version of Roxido. It also helps you to expand the macros so you can see what's happening behind the scenes. You can browse the API documentation, and also you can build packages ready to submit to CRAN. The neat thing about this is it takes all your dependencies that you have and vendors them within your R package so that your R package can be installed offline without an internet connection, which is what CRAN wants. Okay, so by way of getting started, you're going to need to have, of course, R installed. You need to install the build tools. So that means you have to have R tools for Windows installed or a tool chain for Linux and Mac OS. You have to have your compiler, your C++ compiler or your C compiler. But then you need to install Rust, and that's easy to do. For Linux and Mac OS, you can just run this command right there in the terminal, or you can run the rust init.exe for Windows. And both of these can install Rust just in your local home directory. You don't need administrator privileges. Once you've done that, you've got then cargo in your in your shell's path, and you can say cargo install Roxido. Now, Roxido then is my command line tool, and you can make a new package. Suppose you want to call your package RUG26 SLC. You would say Roxido new RUG26 SLC. Then you have a generated package that's already ready to go and installed onto your R, and you can then modify it to your liking. As we poke around inside the generated package, you want to spend most of your time messing with and writing R functions. Well, rather, R functions that are thin wrappers over your Rust functions that you're going to put in the source Rust source directory. You'll notice a few other things that are interesting. The build.rs is this two-pass automatic registration system that like tells R what functions are callable from your Rust code or R code into Rust. We'll poke around in just a minute and we'll see more of the skeleton of a package. In your day-to-day workflow, though, you're going to be modifying Rust functions in the source Rust source directory and also your R wrappers in the R directory. And let's see, I recommend the ROxygen 2 documentation system. And so you want to then provide documentation there. And of course, if you do, you want to regenerate your documentation whenever you modify it. You can also read documentation in the Roxido framework, just using Roxido space API, and that'll launch your browser, and you can see the documentation right there. And of course, you're going to want to install the package. Occasionally, you'll also want to run a few other commands. You might want to run, for example, Roxido expand, which will allow you to inspect the generated code so you can understand what's happening behind the scenes. You can also run Roxido build, which will vendor the dependencies and build a package that's ready to submit to CRAN. And let's see, you can also do Roxido update, which is going to update your framework files to the latest version of Roxido.
We've got a question about that that building piece from folks who have experience, I think, building or getting packages ready to be built from source, for example, on Linux.
Yeah.
Can you speak a little bit to what is it? What is like, how do these packages get built on Linux? Like if you're vendoring all these dependencies and putting them there, what actually does the building if you need to build from source, like on Linux?
Yeah, that's a great question. Why don't we actually dive in and do a live demonstration? I was planning to do that, and I can make sure I touch on that. And if I don't, you make sure you remind me.
Okay. Okay.
That's great. So before we do that, though, let's look at a C function. This is a C function that's provided in the Writing R Extensions manual from the R project. It's the official documentation of the C API. And it's convolve.to is the name of the function. Notice that all functions that you call with the .call interface in R need to take arguments that are SEXP values. These are pointers to S expressions, pointers to R objects. This is taking two of these, A and B, and it's returning, again, a pointer to an S expression, an R object. But notice that like the two arguments, A and B here, we're calling length on them, and we're actually calling real, getting the pointer to the memory. And that's only valid if A and B are in fact numeric vectors in R, that is, have a storage mode double. And if that doesn't, you get this really weird error message that's hard for users to understand. And so really what you want to do then is before you call the convolve2 function, you probably would want to do some type checking in R first before you do the .call to jump down to here. Also notice that you allocated a vector here, and then they call protect so that this R object is protected from R's garbage collector while your function's running. And then when you're done, you have to make sure you call unprotect and get the number in the first argument. This one argument here is the number of protect calls that you had previously. In this case, just one. Okay. Let's go ahead and do the live demonstration now. We're going to see the convolve2 function in the Roxido framework, which is going to be exactly the same algorithm, but it's going to be under this different framework. Okay, so let's pull up here. So I've already got Roxido installed. And so I say Roxido new RUG 26 SLC. And it's going to go then and it's going to pull down from GitHub the latest version of the Roxido framework. Okay. It's going to compile it, it's going to install it, and it was successfully installed. Okay. And then we have a directory now, RUG 26 SLC. So to answer Julia, the question is, let's see. So if we were to want to prepare this for submission to CRAN, we'd say Roxido build. And now it's made for us this package that we can submit to CRAN. If we want to look at what this actually looks like inside, ooh, I imagine this is kind of small for you guys to see, but inside the that's probably too small for you guys to see, but there's this vendor.tar.gz, which has all of the vendored R packages that are available to you. That's what CRAN wants because now they can install this no problem. You could also do a RCMD check as CRAN on this, and it'll go through and do all the checks and stuff like that. Hopefully it checks out just fine. This will check out not perfectly because you have to look, for example, say who the author was and whatnot. But this is the same process you would go through on Windows or on a Mac OS. I don't think we'll wait for that to continue. Let me see first, did we think we answered that question or any follow-ups on that particular question?
That was my question. I was just thinking, if you actually install, if you pull a package from GitHub, or if you're pulling it down from CRAN and you're working on like a virtual machine, which is almost certainly a Linux machine, you will probably you will have to have Rust installed to be able to compile it from source, correct?
Yes, you have to have Rust installed on your computer in order to develop a Rust-based package, for sure. But there's no kind of containers, virtual machines, nothing like that. You can run natively on your
You just
Windows
said
machine.
develop. You just said develop. But if you are needing to build from source an existing package, do you need Rust there?
Yes. If
Okay.
you are going to install a source package, you have to have a Rust compiler to compile your Rust code. Yes.
Okay.
But I want to emphasize, though, that users of your package are almost surely going to be pulling stuff off of CRAN, in which case they'll be pulling a binary, which does not require anything installed, including Rust. Does that make sense?
Not for Linux, though.
For Linux, though, you do have to have a Rust compiler.
Yeah, yeah. Okay, okay.
But let me emphasize that like it's like that's like the least of your worries, I think. Like, I mean,
In terms of like system dependencies and like all the things you would need to build from source anyway.
yeah, I mean, you just
Yeah.
run that one command right there and you've got the full Rust toolkit installed and ready to go.
Great. Thanks for digging into that.
Okay. So it is a challenge, though, to have gotten CRAN to provide a Rust compiler on their build systems, and that was an early thing we had to work through. Okay, so let's go back to the example, and here I'm in my directory, and of particular interest is the source directory, source Rust. And we've got like a crate, they call it, having all the R bindings. It has the Roxido and the Roxido macro. Let's take a look, though, at the live.rs. And here is our implementation of that C function we saw previously. And it's convolve.to. And notice that this function has a Roxido macro decoration that's going to provide a lot of the behind the scenes glue code automatically generated. But notice that our function wants to take two arguments, A and B. But notice we're saying that these really ought to be pointers to doubles, F64s, as Russ would call them. And if someone calls the convolve2 function without it being of storage mode double, maybe someone passed accidentally a function or they passed a list, you'll get a really nice error message that says, oh, that doesn't work. So you don't have to then write this checking before you do the dot call. which is nice. We allocate a vector here, and we're going to initialize it to be have the value 0. Notice that there's this PC object. This PC object is a reference to a protection counter, and this is automatically injected by the Roxido macro. And what that means is you don't have to think about what stuff needs to be protected from R's garbage collector and what stuff doesn't need to be protected. You don't have to worry about making sure that you unprotect like we did here. We had to protect and then unprotect by the same number of things as protect, because Rust will take care of that for us with its drop mechanism. So point is, if something needs to be protected, the Roxido function will require you to pass to PC. And the neat thing about this PC is that its lifetime is just that of this function. And so you're not allowed to store a reference to an R object beyond the execution time of your function. And so a whole class of memory mistakes are completely impossible to do under the Roxido and the Rust framework that we have. Let's take a minute here and we'll say, well, suppose we wanted to add a new function. So suppose I wanted to convert Fahrenheit to Celsius. And so I'm just going to paste in this function. So notice it's decorated with Roxido. I'm going to call F to C. It's going to take a temperature in Fahrenheit, and it's going to convert it to Celsius. But wait a second, if the Fahrenheit temperature is so cold that it's below absolute 0, we're going to provide a nice little error message to the user that says that's not physically possible. Okay, so that's the Rust side of things. But now we need to make a corresponding wrapper function to call that. So I'm going to maybe call that F2CR. All right, so notice that I don't have to do any like checking or anything. I just do the dot call of the function and pass the one argument, and I'm good to go. Okay. Now I'm going to want to, since I have this new function here, and notice I'm exporting it, I need to have Roxigen2 regenerate the documentation and the namespace file. And that is, Roxigen2 needs to regenerate for me the namespace file. And so I'm going to do just Roxigen2, which is just my little wrapper over Roxigen2 : R oxygenize. Okay. And then I'll do just install to install my package. It's going to recompile it. I'll go into R. I'll say library RUG 26 SLC. And I'll say F2C. Let's see, 32 degrees Fahrenheit. That's 0 degrees Celsius. That makes sense. What if I make a really low value for the temperature? Wait, that's not physically possible. It's a nice error message. The point is that your users will never have to know that you developed a package using Rust. They'll just pull something down from CRAN. They'll pull down the binary, and they'll never know, they won't get weird error messages from Rust or anything like that. It'll be all wrapped nicely. Of course, Julia's right that if you, or Andrew's right in that if you're developing on Linux, of course, you're going to need to have the Rust compiler, because CRAN does not provide binaries for Linux. Let's go back to look at this here. But one thing I glossed over is that whenever you write a C function, you also have to provide a special function, rinit underscore and then the package name, that's going to register your functions, in this case, convolve2, excuse me, so that R knows how to call into your package. That registration code happens automatically with the Roxido framework. And so really you could think about what's happening is, there's kind of like 6 steps that need to happen to make your code call your R call Rust. But really, the Roxido framework lets you focus just on writing your function that implements your algorithm. It takes care of all the boilerplate stuff already. So it's going to automatically generate this registration table. It's going to automatically generate code that's going to accept the R objects, the SEXP arguments. And it's going to have this automatic protection on protection bookkeeping that you don't have to keep track of. And it's going to automatically convert back anything that you provide back as an R object when returning. So Roxido takes huge advantage of Rust's very robust type system. So Rust has a very expressive type system. And what that means is then if you have an object that's, say, an R vector, there's some things that you just can't do with it. You can't, for example, call it as if you're calling a function. That's just not possible for an R vector. Whereas R's C API just lets you call any of the functions and pass any SEXP, and then hopefully things work out. And if it doesn't, it messes up your system and crashes and gives you a weird error message. But the type system here that we have in Roxido only exposes to the user what functions are appropriate to be calling for that particular type. Again, the binary users don't need to install Rust. Developers, of course, on Windows, Mac OS, or Linux will have to have Rust compiler. And then we vendor dependencies. What that means is that when we have vendor dependencies and whatnot, is that we don't have to worry about if a dependency that we have, a Rust dependency, increments and maybe changes their API. We can stay on the version that we built against and aren't forced to upgrade. It's a little bit like, have you ever had some R code that no longer worked anymore because somebody on CRAN changed their API and now the function no longer works. CRAN kind of encourages you to always update your code, and maybe a few years later your code no longer works because someone updated something. That's not the case for the Rust ecosystem.
Can you, when you're speaking a little bit just about the building the package and making it available, what about in the distribution and things what about integrations with things I know our universe, will our universe build Rust yet? Or there's the various alternative package managers like Posit makes a package manager and what that. How are things in those kinds of environments?
So yeah, I was using R universe at one point, but decided it was more, frankly, hassle than it was worth for me. Because what happens is that I develop packages. I have my own CRAN-like repository that I post things to for my students that I'm working with. And so I build for them myself the binaries for Linux and Mac OS and Windows. And but yes, R universe, last time I checked a year and a half ago, I would work. I don't know about Posit solution. I've not investigated that. What I'm trying to do is get my stuff once I've got it developed. I want to get up on CRAN. That's the definitive source for me. And CRAN does have all the tools available to install to install your Rust-based package. I guess the one thing I will say is that they have these build tools on CRAN, these build systems, build machines, and they don't always have the latest version of Rust. And so I want to use the latest and greatest, but I think I have to kind of program against the lowest common denominator. And so I think that the Rust compiler on one of the Windows machines right now is a year old.
Yeah. Great. Thanks for answering that question.
So that reminds me, I have a little tool here to help me with that. Roxido Rust versions on CRAN. Rust versions on CRAN. And so the upshot is that, let's see, this is the oldest one. It's from over a year and a half old now, but the other ones are more recent versions. So anyway, I just kind of keep an eye on that and make sure that my code I just developed to that latest version.
Is there a
Yeah.
way that you specify the Rust version that you need on it?
Uh, yes. So, well, first of all, uh, our so the CRAN folks want you to declare that, and so
Mhm.
here I'm declaring that I need version 1.77.2, and also in my cargo.toml file, I say that that's the Rust version that I need.
Do you have to specify it in both those places, or is there a common place that one is extracted from the other?
Um, they are basically separate. This is more advisory to the CRAN maintainers.
Mhm.
So I can't remember if when I update this, if it'll automatically change the other one. I don't think it does. Good question. Thanks. Um, you know what? Let me just wrap up with just a few technical details. I think I've covered a lot of this stuff. Um, the challenge is that uh, R has different ways of thinking about things, and Rust has their own way of thinking about things. R likes to use long jumps for exceptions. Um, and so if your R code calls Rust code, and then Rust code calls into the C API, but the C API wants to throw an exception, that's going to induce a long jump, and that's something that you're not supposed to cross the form function boundary. You're not supposed to unwind over a form function boundary. The point is there's some technical details you have to work out. And so we actually have to like wrap our Rust code in catch unwind to prevent it from crossing the form function boundary. We also have to make sure when we evaluate an R function, for example, we do try eval so we can catch those mistakes. Um, the point is there's one thing to be able to call a Rust function from R just kind of raw, but there's a whole bunch of things you have to think about to prevent yourself from um, causing a mistake. And that's what these frameworks have done for you. Um, oh, let me go back to this example where we had um, okay, remember we had the F2C function, but suppose we pass to it not like a temperature, but instead we pass like a whole bunch of temperatures. Well, this is going to say, oh, that doesn't work. I'm expecting this to be a scalar. Well, why is that? It's because we thought that we were going to get just an F64, just a double. And so that error message was generated automatically by the um, automatically generated code from the Roxido macro to say, wait a second, you gave me something I wasn't expecting. And so then it gives a nice error message for the user. So it makes just things ergonomic and nice for a developer.
Is Rust vectorized so that you could accept a vector and return a vector where it's reasonable?
Well, so what I would do, Andrew, is I would say that's not like if you will, what's called a slice into a continuous spot of memory. And it's a smart pointer, in which case it knows its length. And so there I could then now make my program loop over those elements of the slice. It's not vectorized in the sense of like, it just knows to implicitly make a loop on this. I would need to say for temp in temp. So you do something like that, but of course you're going to want to like store it somehow. And so you're going to need to like make a let um, result equal vector. Um, 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 it's always dangerous to code on the fly here live,
Yeah.
but
Yeah,
you're gonna
yeah,
make
yeah. But you would need to, yeah, great. So you would do it in a for loop yourself to vectorize it.
yeah,
On
Yeah.
the entrance into the function, can you
but
do something like I am passing in an R vector? Or would do you want to stick to the Rust conventions rather than saying
no,
this is
you
an
can also
R
do
type
R
object?
vector. And then if you want to actually type check, you can say R vector I32 if you wanted to, meaning you want it to be an integer, or you could do R vector F64 and it'll type check that for you. Or you could just do this and it's going to not do type checking on the type, and then you have to then check it or convert it yourself explicitly. I wanted to go back to the vectorization though, is that like loops are only bad in a high level language like Python
Yeah.
or R. It's lickety split fast, and that's exactly what's happening behind the scenes in low level languages like Rust and C.
Yeah, so it's not that it's slow, but maybe it's annoying. But you know, like it's not an automatically vectorized language like
Sure.
you know, like shoot, I forget the name of that A one or whatever.
Oh, Ada maybe.
Yeah,
I don't
yeah.
know.
Anyway, yeah.
Yeah. Yeah.
Awesome.
Okay. I think I'll just
Yeah,
end
yeah,
it
APL,
there.
that's right. Yeah, thanks.
I think I'll just end it there just to say that it's oh, let me just show you one more thing, and that's just this. We actually did some benchmarking against the other uh, frameworks, and in nanoseconds, calling the convol function with a small vector was as fast as C, and on long vectors was again as fast as C. Whereas some of the other frameworks doing some automatic conversions behind the scene, maybe some memory allocations and stuff, potentially had this weird slowdown that I couldn't understand.
Ah, impressive.
All right, well, thanks for your attention and thanks for the questions.
Yeah, yeah. Thank you so much. And we can leave those conclusions up while we go through a couple of the other questions. So Mauricio has a pretty interesting question about like what are the libraries that might be available to you, for example, doing matrix algebra. I know a lot of people turn to using C++ to be able to use eigen, like in R, they use C++ to be able to use something like eigen or like maybe you the old one I don't know how to say it, LA pack or La pack or whatever. You know, like these, like a lot of these, like, wait, do you have one that you like that's for linear algebra?
Yeah, so crates.io is the CRAN equivalent for Rust, and R is probably the fastest right now. And here's over 1 million downloads, um, lots of different versions and whatnot, which provides all these nice decompositions and whatnot you'd want to use. There are some other ones that maybe are um, N N algebra is another one, but that one maybe is not as quite as fast. There's another one that recently came out. I haven't tried it yet, but it claims to be as fast as BLOS, which is really cool. So yes, there's things out there. One more thing I'll say is I had another project, and I needed to like have some algorithm implemented, and I just found it available to me on CRAN and or sorry on Crates.io, and I just pulled it in, and it was part of my solution. It was really nice.
Yeah, yeah. Nice. Nice. All right. If folks have another question, you go ahead and either raise your hand or type it out. I will ask you, David. So I work with Russ a little bit now, and I gotta say the dev experience is one of the best I have ever experienced on any language I have ever used over the whatever 30 years, whatever I've been doing this. Like incredible, incredible. One of the best dev experiences ever. In your opinion, what about it like what did they really get right? Like when you like have this experience, like what do you think contributes? Do you identify some of the choices they made or like what makes it so good that you're like, "Oh, this is a pleasure to write this code, to edit it, to build, you know, like distribute." What do you think are some of the things that really contributed just to them knocking it out of the park with the dev experience?
Oh boy, there's lots of things I haven't really thought about a great answer, but a couple things come to mind is that it's super easy to publish your package. Whereas you might be like fight a little bit with Cran to get your package on. It's very easy to publish, very easy to share things. Um, that was a revelation. That was really nice. There also are great tools. There's a great language server protocol LSP
Yeah.
for it that helps you with things. But this the whole idea of like maybe the thing about the whole idea of um, the ownership model and the borrowing model, which is enforced by the compiler, is maybe a little bit restrictive at first. And maybe you can't write the most crazy, totally esoteric things happening in the Linux kernel in Rust very easily without going to unsafe Rust. But for the vast majority of the algorithms I want to implement, I don't find those things constraining and I find them freeing because I can just let the compiler tell me if I'm making a stupid mistake. And then I can use concurrent programming. I can use multiple cores and just makes me productive without having to worry about foot guns.
Yeah.
By the way, I will say that recently Rust is now accepted for writing in the Linux kernel. So elements of Linux kernel can now be developed in Rust as well.
Nice. Nice. All right. So let's wrap up with this last question. So Adam and Kupak want to know a little bit about what are differences or similarities between Roxido that you have worked on and Extendar, which is, I think, another way of integrating Rust into our packages that people may be familiar with. Can you speak a little bit about like trade-offs or like when people might want to think about one versus the other, different sets of priorities? What are
Yeah,
some
I mean,
differences?
to be perfectly honest, the Extendar community is larger. There's several people contributing and trying it out and stuff, and that's great. I appreciate that. Um, and I'm not an expert in Extendar or Savvy. One thing that I didn't like about Extendar is that you have to not only decorate your functions like we do with Roxido, in their case, Extendar, but you also have to like explicitly declare what you're going to be exporting. Like it's twice, and that was frustrating to me. Um, I think Extendar is trying to be more bigger. They want to like provide every possible use case and do automatic conversions for this and this and that for you. And for me, that's a little uncomfortable because I want to know exactly what's happening and not do automatic conversions behind the scenes and have more foot guns. And so I think that the Roxido framework is simpler and also though provides better lower overhead in calling down into Rust and back.
Yeah, great. Great. Well, thank you for answering that. Thank you so much for your preparation. Thank you for sharing this with us. It was really interesting to get to dig into this and walk through this. Thank you, David. Thank you, everyone who came. If you're in the Salt Lake area, you can look for an announcement about our in-person networking gathering next month, and then we will get some more great talks for into the spring.